Yes, it actually prints. Also, today I have a new microphone. Holyland sent me their Lark M1 wireless lavalier to try out, and although I'm not a huge fan of wireless lavalier microphones with having to charge them and whatnot, this one actually comes in a charging case just like your old wireless earbuds, which I really appreciate. And while I honestly couldn't care less about the 200 meter, 600 foot range it reportedly has, or even the noise cancelling, it actually lets me set recording volume levels of high, medium, or low, which is great because I have a powerful voice that I like to use to its best potential, frequently resulting in distorted audio because I can't adjust volume levels in the app. So the Lark M1 is hopefully going to fix my clipped audio issues once and for all. Now, last episode I left you guys on a cliffhanger with the electronics on my DIY 3D printer finished but untested, so since I've meanwhile gone ahead and done first test prints, we need to travel back in time to see how that went.
Flashback.
So the way this is supposed to work is by connecting it to a computer over serial, hence why the USB port on the Arduino was so important. For the software, I downloaded Repetier Host because it seems to be one of the very few slicers that don't entirely rely on an SD card to transfer the G-code. I guess I could use pretty much any other G-code sender out there, but when they're designed for a CNC router, they don't have the nice buttons for preheating the nozzle and whatnot. Either way, the last time I hooked the Arduino Mega up to the computer, which was right after installing Marlin on it, I was able to connect to it, but it pretty much immediately shut down again due to the floating thermistor pins returning erroneous values and tripping over temperature protections. So now, with the shield and everything wired up, I should be able to communicate with it and finish setting everything up. But alas, when I did just that, I was greeted by the one thing I hate the most when working with CNC. An error message. A fatal error on the printer's side. Stop the printer until the error is fixed. Max temperature triggered. System stopped. For some reason, I was still tripping thermal runaway, even though the thermistors should have been providing the sensor inputs with a steady value. Double checking the wiring and probing the thermistors with a multimeter, the heat bay thermistor measured fine at around 5 kiloohms, but the hot end thermistor was dead short. Turns out the screw they used in my cheap hot end kit to keep the thermistor inside the heater block was screwed in with such excessive force, it chafed its way through the insulation and literally shorted out the sensor. And after fixing that, the thermistor was just fine. So next, I tried to plug in the first power supply, the one for the Z-axis motor, because up until now, only the Arduino was running, powered by the USB port. Yeah, it's working! I can't believe it. It actually worked first try. And so did, miraculously, homing it. Now, as much as I'm used to my electronics never actually functioning when I power them up for the first time, the entire test of my DIY controller shield was pretty anticlimactic in hindsight. Of course, there was a moment of apprehension every time I plugged in a new power supply in case something would release the magic smoke. Nothing happens. Is that a good thing or not? But each time I was pleasantly surprised, it just worked. Oh yeah, it's working! Obviously that was to be expected since I literally just copied the RAMS board for my design, but you know how easy it is to make stupid mistakes when creating a PCB. The X and Y axis motions ended up being inverted, which was rather easy to fix by simply flipping the stepper motor plugs. Now, the one thing I was most worried it would fail was the MOSFET switching the heaters, because as opposed to all the other components on the board, I had used pretty much random ones salvaged from e-waste instead of the ones listed on the original RAMS 1.4 schematic. But again, it worked like a charm. The hot end heated up, I was able to extrude filament, the part cooling fan ran fine, and the heated bed got warm. We have a warm heated bed! So it was finally time to try printing something, and since I'm still more used to CNC router type machines than 3D printing, I somehow wanted to do a practice run first without actually extruding anything, and I already had it going when I realized it was preheating the nozzle and about to embark on the real deal unless I actively disabled the extruder. So I quickly stopped it again, and after changing my mind on the dry run and leveling the bed, I was ready for all my hard work of the past 2 years coming to fruition. It's printing! Oh my goodness! This is insane. Printing another one of those? It's horrible, but It's printing! Can you believe it? Oh my goodness. Can you believe it? It's printing. It is a 3D printer. Oh my goodness. It just works. Well, it doesn't work very well, but it is printing. Can you believe it? It's actually printing. Just look at my face here. There I am, never having seen a 3D printer in person before. Spent 2 years of my life building this thing because I made videos about it for the internet. Have no idea how to use a slicer or what settings to use, and this thing just starts printing. That is absolutely amazing. Like, I had no idea what settings to use. I just ran with something, and it is printing. That is incredible. It makes a hell of a lot of noise, but it's printing. It's printing! Oh my goodness. It's not gonna be a good cube, but it's gonna be a cube. Oh my. I cannot believe it. This is so weird. Now, unfortunately, this print failed relatively soon after due to the filament breaking and jamming the extruder. Now, let me just say, I have no idea why I kept trying with this horrible filament. I purchased it 2 years ago, and even though I never opened the sealed bag until recently, it soaked up so much water over that period, it sputters and foams up during extrusion like crazy. And maybe it even degraded because it gets pretty liquid at the 200 degrees I was printing it at, even though on the label it says 205 to 220 degrees. Either way, it is in no condition to do any printer a favor. However, I pressed on with the next attempt anyway. And that is the very first successful 3D print finished. If you can even call it successful, that is. It's very slanted because obviously the X-carriage is moving relative to where it should be. I already hinted at something like that in episode whatever it was, and obviously it is happening. The X-carriage is moving over time, so Airy print will probably be like this until I do the lead screw upgrade, but since I need to do the lead screw upgrade anyway to get a better resolution, I don't need to worry about that very much. The horrible filament is probably not doing it a favor. I mean, the printer isn't that terrible, I guess. I mean, we do have a very long Bowden tube. People were worried about stringing. We do get some stringing in here. We get weird extrusion issues. Probably the fact that I only have one part cooling fan isn't helping it either. So this side is weirdly extruded, but a good chunk of that might just be the filament. This filament is absolutely awful. I don't know what's wrong with it. I'm gonna try the other filament next, the yellow G-Tech one, and see if that's any better. Okay, now I really owe you the explanation for why we're getting these insane amounts of layer shifting, and let's just ignore all the extrusion issues, most of which were indeed purely down to the crappy filament. So as you might have noticed, we're really only getting layer shift in the X direction. The Y-axis is pretty much perfectly straight. That's because, as those of you who followed most of the series will know, I used this wonderful 90s technique of a tension fishing line wrapped around a drive drum for the linear motion mechanism. And the only difference between the X and Y-axis is that the Y-axis motor had already been used in that very configuration to move the carriage of the typewriter that I got it from back and forth, while the now X-axis motor used to spin the daisy wheel. On the spur gear of the Y-axis, you'll notice this big cylinder section the string is wrapped around, which, for the lack of a better designation, I call the drive drum. Now, if I move my model here back and forth, you can see the coiled up section of string creeping up and down on that cylinder. And despite theoretically introducing an ever so slight cosine error into my positioning accuracy by bending the string outward or inward whenever the carriage is not in the middle, this is actually vital to functionality. On my x-axis gear, there was no cylindrical section, just a tiny groove for the daisy wheel to snap into, and because adding one would have tanked my steps per millimeter ratio due to the increased drive drum diameter, I simply ran my fishing line inside the groove. Now, with the string suddenly trapped between two flanges, it cannot move up and down anymore, so it tries to climb up the flange to get there, which ultimately doesn't work, and the entire winding has to slip up the groove to make space for any new string to be wound up. And as you might have guessed, on a rotating cylinder, it doesn't just slip axially with the rotation, it also slips in the rotation itself, because the one premise this entire method of propulsion is based on, friction between the string and the drive drum, got violated. Now you might wonder, why does it creep primarily to the left and not equally in both directions the way probability would suggest? Simply because in a mechanical system with a random component like this, one direction always comes up on top due to the tiniest irregularities in literally anything. In this case, it might be the surface finish inside the groove and of the fishing line. I don't know, it doesn't matter. Now, if you don't want to spend 2 years building a 3D printer just to find out it's a natural at printing poop emojis, PCBWay have your back. They have a huge variety of materials and processes to choose from: resin, nylon, PEEK, ABS, PLA. I'm pretty sure their PLA will be better quality than mine though. Polycarbonate, TPU, you name it, all the usual stuff, plus materials we could never dream of 3D printing ourselves, like aluminum and titanium. And best of all, you get those parts sent to your doorstep within just a few days. Big thanks to PCBWay for sponsoring this video. Now back to my poopy prints. You might be slightly confused right now, wondering where all the layer shift went on that emoji. No worries, it's still there if you look closely, just much less pronounced. Turns out, the simple act of tightening the fishing line was enough to rein it in to a much more acceptable level. The next cube I printed, a big one at twice the size, was already much straighter, even though you can still see a lot of under extrusion pretty much everywhere. This was with a 1mm nozzle and 0.4mm layer height, by the way. I also ended up printing a few little boxes to try various settings, but those came out progressively worse. The only other thing we can learn from these tests is that my single-sided part cooling fan is definitely having an impact, as on all these prints you can see the right-hand side corners are a lot more blobby and melty than the left side where the fan was. So the green filament was obviously garbage, and to find out if this printer is any good, I needed to use something better. Fortunately, I had bought some G-Tech PLA just 6 months prior, so I got that unboxed, and oh my god, was it a lot better. It didn't even snap into 1,000 pieces like dry spaghetti when I bent it. And I couldn't believe my eyes when I printed the first test cube with it. The first layer was almost closed, the letters were legible, the sides smooth, only the top was almost as bad as before, but I suspected the slicer to be at fault for that, and most importantly, there were far fewer spots suffering from under extrusion. Measuring the dimensions really didn't make any sense yet, but ironically, it was pretty darn close on both the X and the Y. I was so impressed, I immediately switched the 1mm nozzle to a 0.6mm one and printed another cube with 0.2mm layer height. As expected, that one came out a little more detailed, but not really any different overall. And that's where I'm at right now. With a decent filament, it prints in a way that, while it couldn't be described as good in the grand scheme of things, is certainly good enough for us to actually see some of the inherent issues and to start using it to print parts in order to improve it. Taking another look at these cubes, we see a mind-boggling amount of ringing and bulging corners. I did expect some heavy overshooting of corners simply from the large squishy steps of the motors swinging those carriages around in 0.1mm increments. Just listen to the way it sounds. That cannot be good. And since that'll totally disappear once I install lead screws on this thing, I'm not even gonna bother trying to fix it right now, unless some change in settings happens to reduce it anyway. The messed up top infill indeed turns out to be a slicing issue. These parts were sliced using Cura engine in Repetier host, and if I do it again just now, you can actually see it trying to lay down the solid infill for the Z mid-air. Like, that's never going to work. In addition to the fact that top and bottom thickness was set to 0.6mm, which at 0.4mm layer height somehow works out to 2 layers. I told you I had no idea how to use a slicer. However, since in the meantime I gathered a lot more experience using Prusa Slicer, and now have at least a rough idea of what most settings do, I'm going to use that to slice all my models from now on, and use Repetier host exclusively to control the printer. Much more concerning is that we're still getting some occasional under extrusion here and there. That in itself isn't surprising either, considering I used a 28BY-J48 for the extruder and didn't shorten the Bowden tube. People in the comments told me I would get under extrusion, and I guess you guys were right. Since I realized I could have mounted the extruder all the way at the top of the gantry, thus eliminating about 6 inches of unnecessary Bowden tube, I'm gonna take care of moving it up there right now before doing anything else. Of course, I don't want to redo all my cable lacing, so I'm gonna secure the last nut I want to keep with super glue first. And now my stepper motor cable is too short to plug into the driver, which is the exact reason why I didn't put it up there originally. So I'm gonna have to whip up a little extension. Finally, I'm also going to torture that 28BY-J just a little bit by replacing its 5V power supply with a 6V one. Someone in the comments mentioned they don't necessarily burn out on 6V, so we're doing it because I need every little bit of extra torque I can get here. I will go back to 5V later though, because when I install these screws, I'm also going to put the extruder on the X carriage together with the hot end in a direct drive configuration. So that'll get rid of the Bowden tube altogether, and thereby theoretically should require much less torque from the extruder. Anyway, let's set it up to print something. I'm pretty sure you already gagged at the idea of having to plug in this many power supplies for a single 3D printer, and yeah, you need a switched power strip for that not to be a pain in the butt. True to the original spirit of the project, I took this one that had stopped working due to the switch contacts being dirty, drilled out the heads of those god-awful unkeyed screws, big Fs in the chat for any company trying to keep me out of their product, and cracked it open to take out the switch. Those generic switches can actually be popped apart with a screwdriver, and yeah, just grimy contacts. Sanded those fresh and clean, reassemble it using super glue to replace the annihilated screws, and wouldn't you know, it works a treat. Of course, it would be pretty inconvenient having to drag around my normally stationary editing computer to stream G-code to my printer every single time I want to 3D print something, so I coaxed this 2009 netbook out of my dad, who primarily used it as a paperweight on some pile of trash, and installed a lightweight Linux distro on it called Q4OS. I did a short about that some time ago, so now I have a dedicated user interface for my 3D printer. Since I'm kinda allergic to tiny screens, I also dug out this thing they used to call a TV back in the day to actually be able to see what I'm doing. So that is why I've had this e-waste collection on my table for the past like 6 months, just in case you wondered. Anyway, let's print a new cube, hopefully without under extrusion. Uh-oh, the unthinkable happened. My print bit just cracked. I figured I would manage to smash it sooner or later, but Earlier I noticed there was a tiny crack in the corner going to that screw hole. I figured it wouldn't propagate past the screw hole, but when I was heating it up right now, it just went right there to the middle of the print bed, which is not good. That's the last thing I needed to happen right now. Of course my print failed too because I turned off the heated bed as soon as I saw the crack spread, so the cube detached from the bed as it cooled down. This is definitely one of those situations where you just want to click undo in real life and make it so it never happened. I don't even know when or what I hit it with to initiate that crack. I guess we're gonna have to print our cube and Benchy on an unheated bed then, until I get an entire new heated bed made for the next episode. What I wanted to say before all this happened is, I'm giving it the best chance at working this time by using a known quality filament, namely some of the leftover Two Trees stuff. I'm sure the G-Tech filament works just fine, but I know for a fact this somehow extrudes more evenly. Only downside, it has a matte surface finish, which does provide more friction in the Bowden tube. So here's the test cube. I removed all heat bait commands from the G-code, and just to be safe, I'm also going to unplug the bait power supply. Can't risk that crack propagating any further and breaking the bait in half. Let's crack out the glue stick of shame and see if we can print stuff regardless. Power is on, nozzle heated up, let's run the job. It's homing. There it is, purging. I really hope that sticks. Doesn't really look like it. Oh yeah, there it goes. Well, that's the grand finale of my video thoroughly ruined. I was planning to print a few other things as well in this episode, namely some bait leveling knobs and an air duct for the part cooling fan, but it doesn't look like that's gonna happen now. I guess glass is glass, and glass breaks. I was really afraid of something like that happening ever since I made that bait. After all, the design with just a heated glass plate and nothing else to mechanically support it is quite fragile to begin with. Plus, with making these videos, I tend to handle most parts at least twice as much as I would if I just built this thing for myself. By the way, it's printing with a 0.6mm nozzle and 0.3mm layer height. Not gonna lie, watching 3D printers is pretty boring, and filming them is even more boring. Still nowhere near as good as I hoped. The top certainly is a lot better now with proper slicing, but the solid infill still isn't fully closed, and I'm also still getting these weird artifacts. Certainly looks like under extrusion, but I'm not entirely sure. If anyone knows, tell me in the comments. I'm gonna try the exact same thing again with the yellow G-Tech, just to see if there's any difference. This certainly slides a lot better in the Bowden tube. And that first layer is a lot better if you ask me. Can't really show you because the printer is in the way. I didn't actually plan on recording this cube at all, but seems like the first layer is a lot better.
20 minutes later.
And there it is, done. At least it's not lacking in the bait adhesion department. Ugh, can't get it off. There we go. Not too shabby. I guess it was under extrusion then. Those artifacts are all but gone. That is pretty good, actually. Look at that. We're still getting some artifacts from the stepping of the motors, but this is pretty neat. Even the first layer is almost totally closed. Interesting. So with this Bowden tube, I'm really operating at the very limit of what the 28BYJ can deliver in terms of torque. Let's do the stupid thing and switch to a 0.4mm nozzle and 0.2mm layer height. Stupid because with a 0.1mm overall resolution, if the carriage moves just one step further, you immediately get 25% overlap or even gap between two adjacent filament strings. I actually saw one of those gaps on the cube already. Right here, the outer perimeter is slightly detached from everything else. That's what you get for crappy positioning accuracy of your printhead. Then again, if I measure this cube, it's surprisingly accurate still. Like, of course it depends on where exactly you measure it because of all the ringing, but overall, it's pretty good.
More moments later.
That generic V6 hot end is a huge pain in the butt to change the nozzle on. I had to take the whole thing apart because the stupid heat brake constantly unscrews from the heatsink. Of course, not helped by the fact that my neat cable management doesn't let me pull out the Bowden tube at all. And the silicone sleeve only stays on there with a wire around it. Anyway, XYZ calibration cube with 0.4mm nozzle coming up in 3, 2, 1. This is pretty good. Honestly, I cannot complain considering just how much jankier this printer is than a real machine at least 4 times the cost. Not to mention, we're working with a resolution of 0.1mm here, which is literally an order of magnitude less than what any standard 3D printer does, and yet we still get parts like this out of it. I mean, it is a shame it has this chronic layer shift going on, making ArriPrint slanted, otherwise these would be some totally usable parts, but it's pretty impressive nonetheless. Plus, this is nowhere near the end of the road yet. I still don't entirely know what I'm doing in the slicer, and with a bit more tuning, parts could probably turn out even better, and as soon as I install lead screws, all those other artifacts you saw there should just go away as well, leaving us with totally acceptable 3D prints from a 3D printer built out of trash using technically unsuitable stepper motors controlled by what amounts to e-waste. But I know what you're really waiting for. It's this infamous little guy here, right? Well, your wish shall be granted. Here we go. I have definitely seen better Benchies in my lifetime, not gonna lie. It's interesting what the constant layer shift does to a more complex model, because of course, as some layers take longer to complete than others, the printhead shifts more overall on those. That's why the bow looks a lot more smushed where all the solid infill for the deck is, and as soon as the hull is finished, you can see the cockpit straighten out a bit. Also, as expected, there is no visible layer shift in the y-axis, since, save for the abysmal resolution, it works just fine. There is a lot of stringing. I disabled retraction because with an extruder this slow and a Bowden tube, it oozes even while the extruder is in the process of retracting, so it didn't really do any good and unnecessarily increased print times. So obviously I've still got quite a ways ahead of me if I want to get decent parts out of this printer. It's definitely doable, but I may have cut a few too many corners and knowingly set myself up for failure with that X-axis fishing line. It's kinda ironic because in my very first draft of this machine, I was totally intending to use lead screws, and then I thought, oh no, it'll be so slow, people aren't gonna like it, plus I need to get so many things parallel, and I went with fishing line when I really should have trusted my gut and used lead screws. What's the bottom line? If you just want a 3D printer, buy a broken secondhand one for cheap and fix it. If you're looking for an adventure, by all means do what I did, take an old typewriter and go to town. I guess that's it for this video. I'm gonna make a new heated bait from scratch the exact same way I did this one off camera, and I'll catch you in the next episode where I'm going to talk about everything I need to improve on this machine in order to have it spit out acceptable parts. Benchies that maybe don't look like a pug or like they ran into a brick wall. Turns out, there may actually be a reason nobody tried building a 3D printer for $50 until I came along. It's really hard and just not worth it. Thanks to Holyland for sending over the Lark M1. It's a decent microphone, easy to use, and to me at least, the charging case is a prerequisite to a wireless lavalier. Although, sound quality wise, and this may come down to personal preferences, I'm not an audio expert, I cannot say it sounds better than the wired Boya I've been using up until now. Certainly, if the Boya didn't pick up as much breathing and gulping and didn't distort every time I opened my mouth, I would prefer it. But again, that may just be personal preferences. Also, special thank you to the kind people supporting these projects on Patreon. I'm really learning a lot just talking to them on the Discord. They are a lot smarter than I am. Hope you enjoyed. I'll see you again ASAP. Bye bye!